Hi, so I would like to briefly talk about an attempt of mine to implement a sort of macro in Shackle, which is a constraint language for RDF graphs. And so this isn't about Lisp, but I hope it is reasonably Lispy to be of interest for talking about on a Lisp conference. So first of all, a quick introduction to the to RDF graphs and the W3C semantic web stack. First of all, there's RDF, the resource description framework. Basically, it is a data model that is built around triples, that is subject, predicate, object constellations that are used to build directed multigraphs with labeled edges, and it's primarily used for knowledge representation and building knowledge graphs. It's not relevant for this talk, but it's an interesting thing. Basically, what it is a description logic-based axiom language that allows to run an inference over a given RDF graph. Sparkle is a query language I will show in a second. I will show a minimal example of Sparkle in a second. And finally, Shackle, the shapes constraint language. It is a constraint language for RDF graphs, basically much like a schema language for XML, but for RDF graphs and some others. So basically, this is Sparkle. It's a SQL-like query language for RDF graphs. It allows to select it allows to pattern match and select triples in a graph. And there is also a construct which allows to pattern match and actually generate triples based on this. So the construct example here is a very, very minimal example for construct query. And what it does is it basically copies a graph. It matches every triple in the graph, and it generates those triples. So Shackle, as I mentioned, is a constraint language for RDF knowledge graphs. Basically what you do is you define a shape with a target. In that case, this is a very minimal example. Actually, Shackle is reasonably expressive, and Shackle shapes can become very reasonably complex. There's a very minimal example. It basically says that any instance of an X bool class needs to have exactly one value that is either true or false. So given that shape, those triples would actually pass, and those triples would fail validation. So how does Shackle processing work? Shackle takes a shapes graph and a data graph, both go into a Shackle processor, and it generates a results graph. So this is very graphy, and you might have noticed that the basic example shapes graph that I showed you is expressed in RDF. So basically, Shackle uses RDF to express the rules for RDF, which is essentially homoiconicity, right? So this is pretty interesting, maybe. And another thing that's interesting is Sparkle rule. It's defined in Shackle advanced features. And what it does is it is a Shackle rule that allows you to construct triples during Shackle processing. In that example, for that shape, for example, says that if you match a triple with a predicate P, then Sparkle construct a triple with a predicate Q. So given a data graph, you're in target XP and some literal, it will generate during Shackle processing a graph, basically two triples, with XQ constructed through the Sparkle construct query. So given those two ingredients, basically what we have is all the ingredients necessary to do something like a macro, right? We have a sort of homoiconic language construct, and we have a way of asserting triples, asserting that data structure. So what I did is I tried to implement if then else in Shackle. Shackle does not natively have conditionals, but it has and or not. And it is possible to implement if then else in terms of and or not. So this was basically what it does. I defined these predicates if then else, and it sort of macro expands into Shackle or and not expressions. So I feel like, so some example of passing validation and failing validation. So, and I think this is a very classical example of macro expansion. You build an abstraction that macro transforms into something lower level. So maybe a very traditional application for macros. The problem, the caveat of this is, basically what you need to do is for every macro expansion you do with a technique like this is you need a Shackle process. So if you wanted, for example, to define something like elif in terms of if then else, you would need a third shackle process for that. So every macro expansion step needs its own process. So if you define a macro in terms of another macro, basically this shows how problematic this is. So are shackle macros actually useful? Probably not really, but it's fun to think with this stuff.
Thank you.